how to calculate peak area, and from that peak area, how to count how many protons are present in the molecule giving the NMR spectra. So in NMR spectra, number of peaks is equal to number of sets of proton. If you are getting one peak, that means there is only one set of proton. Listen carefully, I am not saying it has one proton, I am saying it is one set of proton. If there are three peaks, it means there are three sets of protons. It does not mean there are three protons. It means there are three sets of protons. There may be 10 protons also overall, but they will be in three sets. Okay. I hope you got the first point. Pretty much easy. Then size of the peak or area of the peak are equivalent to number of equivalent protons. Equivalent protons means protons which are in the same chemical environment. Okay. So size of the peak or area of peak is relevant to, is correlated to, is equivalent to number of similar protons in set which absorb energy at same effective magnetic field. Then there are two methods of counting of protons. One by square under peak, and second integration of peak. Now let us start with first method by square under peak. What happens in that? Now there is a graph paper. Okay, what can be done is, on that graph paper, suppose I will try to draw one hypothetical graph paper. Now it is difficult to draw those straight lines on the computer. So suppose there are further divisions of the square, it will be difficult for me to draw it. Okay, there will be horizontal lines also, and suppose there is a signal. Okay, so for this signal, this is the baseline which I have just drawn. This is baseline. So all the squares under this curve, this triangular shape, let me highlight that. Should I select? So in this area, they count how many squares that are covered. Okay, so number of peaks covered in that region of the peak. Okay, that is counted. So for example, in the spectra of toluene, you observe two peaks. Add the square under two individual peaks and take the ratio, simplify the ratio. Suppose, I hope you understood how to count these peaks in one area. In toluene, there are two such peaks. Okay, suppose in one peak there are 35 squares covered, and in the second peak, suppose 21 squares were covered. Okay, so what is the ratio? 35 to 21. If you simplify the ratio will become pi is to 3. Divide both numbers by 7. Okay, so this is the simplified ratio. I hope you got it. So you have two signals. Okay, so in one signal there are 5 protons, and in the other signal there are 3 protons. Now whichever signal is downfield towards left hand side, it will be downfield. So 5 proton wala signal will be downfield, and the other set of proton will be completely upfield. Now on the graph, smaller size of square is equal to more accuracy. So I have drawn, suppose this size of square. If we can further divide squares into smaller squares, the resultant will be more accurate. Okay, now there is another method of counting. It is integration method. Okay, it is called as integration method. Now I will read out, then you will understand it better. I will explain it. The method is called as integration of peak. Now this is the modern method. Modern instrument use this method. The NMR instrument integrates the area as follows. When there is no signal, it draws a horizontal line. Like the line drawing will be starting from here. Let me use the highlighter. Okay. Now till this region there is no signal, so it is horizontal line. When signal arrives, the line ascends and levels off as the signal ends. That means this line will ascend as the signal is there, and then it will stop. Okay, then it will stop. Again there is no signal, so there will be a plateau region. Another signal arrives, again it is rising. Again no signal, again there is a signal, so again it will rise. So the question is how to decide how much it is rising. So that rise in the line, lies in the curve, depends on what area is covered by the signal. More the area covered, there will be higher the rise. Now, one confusion should be avoided. This may be a sharp signal, and this is comparatively a wider signal. The sharp signal you may expect, because it is high in its height, is covering a larger area as compared to this wider signal, but this may not be the case always. Okay, it depends on really how much area that curve is covering underneath it. Okay, so height doesn't matter. How much area is under that curve, that is the important thing. So the relative distance from plateau to plateau gives the relative area. That means from this plateau to this plateau, the rise is of 51 units. Then from this plateau to this plateau, the rise is of 21 units. Then from this plateau to this plateau, rise is of 32 units. So you will take the ratio 52 is to 21 is to 32. So if you can simplify it, the ratio will be twice to 2 is to 3. So this is the ratio of protons which are giving those signal. Next point, spin-spin splitting. Now, often a hydrogen which is present in the molecule may give a signal consisting of single peak, or it may give a signal consisting of multiple peaks. This is called as splitting of the signal. Single signal is split into several peaks. This is called as splitting of the signal. This splitting is observed because of spin of the protons, which is adjacent to the proton giving the signal. Okay, that's why it is called as spin-spin splitting. So I will go through the points and I will explain them one by one. Often a group of hydrogens will appear as a multiplate rather than a single peak. So you are not observing a single peak, you are observing multiple peaks as a single signal. This happens because of interaction with neighboring hydrogens, and it is called as spin-spin splitting. Now, non-equivalent protons on adjacent carbons have magnetic fields that may align or oppose the external field. Now, this spin-spin splitting occurs between non-equivalent protons only. So, if such protons are present on adjacent carbons, they are neighbors of each other, then they will align themselves as per each other or opposite to each other. The magnetic coupling causes the proton to absorb slightly downfield when the external field is reinforced, and slightly upfield when the external field is opposed. Now, suppose there are protons. These two protons are on adjacent carbons. Okay, they are each other's neighbor. Now, when external magnetic field B0 is applied, there is two possibility. Both of them, they will have the same spin, or they may have the opposite spin. When both of them is having same spin, let us consider this as proton A and let us consider this as proton B. I want the field experienced by proton A. I want to calculate that. In the case on the left hand side, the direction of the external magnetic field and the direction of proton B is same. So, magnetic field experienced by B will be somewhat more than B0 which is applied. So it will be because of B0 external magnetic field and magnetic field of adjacent proton B. So this is condition number 1. In condition number 2, the magnetic field of B is opposing B0. So magnetic field experienced by A will be slightly less than B0. So I will read out this point again so you will understand it. The magnetic coupling causes the proton to absorb slightly downfield when the external field is reinforced, and slightly upfield when the external field is opposed. I hope you people understood this. All possibilities exist. So, signal is split. The last statement states, like, suppose there are such 100 molecules. Out of 100 molecules, say in 50 of the molecules, the field is reinforced, and the remaining 50, the field is opposed. So when all these 100 molecules are measured simultaneously, you will get two signals, one for slightly downfield, one for slightly upfield. So both the signals will exist side by side. Now, if you have understood what is splitting, let us see the rules for signal splitting.